There you go.
All right. Hi, everybody. I'd like to thank Ian once again I called him up whenever it was, yesterday, I guess. And he's found the 4 images, which we may or may not get to today, but we'll try. Before we get started, Debbie, are you there? Can you hear us? We can't hear you.
I didn't unmute. I'm here, MaryLu. I'm here.
All righty. I would like, if you don't mind, I'm assuming you looked up at night when you were in New Mexico last week. How were the stars different there? What was your elevation? Were you up 4,000 or 5,000 feet at night? Can she hear us?
Mm-hmm. I think so.
I know, she doesn't seem to be responding. Debbie, did you hear my question?
No.
No, I didn't, but I can hear you loud and clear now. So what's the
Okay.
question?
When you were in New Mexico, I assumed at night it was clear and you looked up, I would hope. How were the stars and what was your elevation? 3,000, 4,000, 5,000 feet? How were the stars different?
We were at about 6,000.
Okay.
And we had clear skies. It's just that I think the stars are in a different place or something.
Yes. Different how?
I don't know how. Lower in the sky. No. I don't know. I know we tried to figure out where things were and we had a tough time. It didn't look the same as home.
I think that's maybe a perfect psychological example of how you're so rooted, especially in the past. I mean, nowadays we move around a lot of us, but in ancient times, people pretty much never went 6 miles away from where they were born. And so what they saw is what they saw, and they just assumed that's what it was everywhere, I guess, if they even thought about it. But that is not true, is it, Debbie?
No, it did not look the same.
Anybody want to chime in? Let's pick one star. Did you see a particular star or not? Or a constellation? Or just stars?
I don't remember. We just were out looking and it was beautiful because it was just huge open sky country, I guess I want to say.
All right, let's then theoretically pick the planet Jupiter, which we've been looking at this summer. Anybody else out there want to tell Debbie, if she's further south down in New Mexico, how would Jupiter appear in her sky compared to, say, the southern horizon? When you were at my house, we always looked to the south pretty much, and Jupiter was at a certain height above the southern horizon. So anybody, where would Jupiter be down in New Mexico? MaryLu.
I think it would be higher in the sky than what it is here because she also could see part of the southern hemisphere from where she is, I'm assuming.
Yes, the further south you go, the higher those southern stars appear in the sky.
Yeah.
Yep. And the opposite was true when I went north to Finland. Then the only part of Orion, which was tipped on its side, I could not see Rigel, which was below the horizon. So it's the opposite as you go north. The stars seem to go further down towards the southern horizon. Any other comments on that before we move on?
Well,
yes.
When we went to Hawaii,
all right,
there the moon seemed to be upside down from where it was here. And they have a different, we look at the moon and see the man in the moon, we see the face.
All right.
But if you turn it, and I don't know if it was just turned sideways or upside down, but because Hawaii isn't halfway around, so probably it was just sideways, but to them it was a woman. And you could see the woman sitting on something and
All right. Do you happen to know the latitude of Hawaii? Are they still in the northern hemisphere, or are they south of the equator?
No,
Bob?
they're still they're about the same as San Francisco. I would
Really?
say they're still in
Oh.
the northern hemisphere.
Bob, do you happen?
Yes, they're definitely in the northern hemisphere, but I think they're a little further south than San Francisco. My memory is about 20
Okay.
degrees
Yeah.
latitude.
19.89.
Oh, okay.
Okay,
Got
about 20 degrees. So they're 20 degrees further south than us, which is roughly 1,400 miles further south than we are. Which would put us about the tip of Florida, I think.
Yeah, I was just gonna say that would put us around Florida.
Mm-hmm. Now, okay, we
Well,
can
anyway,
off the
thought
top.
was interesting.
Okay, off the top of my head, I'm going to jump out on a limb, and you can all disprove me. He has already got his magic box here ready to go. I think we see the same moon there. It's just they have different legends connected to it.
Well, I couldn't see the face, but I
Yeah.
could see the lady.
Well, but once again, if you tell a child the dessert is going to be sweet, they're going to assume it's going to be sweet, and they're going to probably taste it as sweet.
Mhm.
Mm, I think, but I'm not sure. We'll do some research on that, MaryLu, and figure that out, whether the moon looks different from down there.
Okay.
Anybody know off the top of their head? We're not really doing very well on the top of our head today, are we? All right. So before we go to questions and homework, I wanted to start off. We've been talking a lot over the almost 8-9 months, whatever it's been, about how far things away are, what they're made of, how much they weigh, how, what their mass is, how fast they're going. And I think it's the point now that we got to stop and say, oh yeah, how do they know that? How, especially 100 years ago, 200 years ago, 1,000 years ago, no one went out there with a measuring tape. And until recently, nobody went out there and scooped things up like the moon rocks and sent them back to us to analyze. So how do we gather all this information? So we're going to start in this time, and then we'll move through the next couple of sessions talking about different aspects. Now, while I babble on for a few minutes here, I'm going to chase Ian. I gave a book to the library with that picture, the electromagnetic spectrum, and I think we still have it. If you could find it.
Do you know the title?
No.
It was about,
The electromagnetic spectrum. So it'd be in physics probably, or
the
light.
whole book was about?
Yes, it started with radio waves and it went all the way through gamma rays. I think I saw it sitting somewhere recently. Well, I chased Ian to get a book that we're going to look at. And while he goes and do that, I'll give my introduction here. Somewhere recently, I read something that I thought that is really, really true, that knowledge is limited on how well we, and this is mostly in astronomy, but you can apply it to really almost everything. Knowledge is limited to how well we can see, eyes, see, in other words, observe, and reason on what we saw. So for us in the West, anyway, this concept of science went back to the Greeks. They were famous for their observations, and then they used their reason to work out, often mathematically, what was going on. And an example in astronomy would be way back in the day, people observed with their eyes and concluded that the Earth was the center of everything. It was only roughly in the 1400s with new equipment that enabled them to see better, that people and reason about what they were really seeing, was that whole concept shifted to placing the sun at the center of our solar system. So that was one thing I thought was really a very interesting idea. You could probably write books and books about it. The second was that science looks to the past to predict the future. That there is an underlying belief that the laws of math and physics are consistent throughout the universe and throughout time. What happened then is happening now and will happen in the future. And therefore, if you base your observations in a mathematical framework, you can suddenly predict exactly when that comet was going to run into Jupiter, practically down to the second. Pretty amazing when you think about it.
It is, isn't it?
Yes? What's that?
It is, isn't it?
It is.
I think it
And-
is very amazing.
And of course, as soon as I said it looks to the past to predict the future, what popped into my mind? Astrology, which is all based on making observations about the heavens and what they're doing, and then predicting what your life will be like here on Earth because of where you were when something up there happened. But anyway, all righty. Now, several people were absent last time, but I think I'm going to run through some questions that I think I gave out. If you have the answers, if not, you can just jot them down for next time. All right. Now, Debbie, did I give you what is the distance, or what is a light year and what is an astronomical unit? Do you remember that? Did I ask you that last time?
No, because I wasn't there last time.
All right, so that will be your question for next time. What is a light year in distance related to time? And then something called an AU, not the university, but an astronomical unit. How many miles is that? Or how long is that?
Got it.
Okay. Now, MaryLu, did I ask you for the distance in miles, both to the sun and the moon?
Yes,
Okay, so this is my list. All righty, did you come up with that in miles?
yes. It's
Okay, that's not it.
238,855 miles.
To what now? Ian just popped into my, say again, I'm sorry.
238,855 miles.
Okay, almost a quarter of a million? I always rounded it off to
Almost. A
250,000.
little bit more.
Okay, all right, almost, okay. That's to the moon. Took about three days for the guys to get there, I think, and then 3 days home. What about the sun? How far away?
92,955 and 807 miles.
Oh,
I always heard it was 93 million miles.
it is now. However, that's the average. You see, in spite of Plato and his love of circles, most orbits are not a perfect circle.
Yeah.
So
right.
the orbit that the Earth takes around the sun is slightly elliptical,
Yeah.
slightly oval. So, and then the sun is not in the center of that, but at one of the focal points, which means at one time of the year, in the winter for us, oddly enough, we're closer to the sun. And in the summer, then we're further away.
Right.
And the average is 93 million miles, rounded off. Okay. Who else was here? Let's see. Sandy's not tuned in, right? Okay.
What was her question?
Her question was, well, it depended on Debbie's. So I'll give one answer to Debbie's question because the rest all depend on that. 93 million miles is a big number. But when we start measuring out to, say, Pluto, it's going to take up a lot of paper to write all the zeros. So astronomers decided we needed a new unit of measurement, you know, like what's a foot? A foot, by the way, I think is 13 barley corns in the Middle Ages. A barley corn, if you lined them up, 13 of them was the average size of a man's foot. Or when you measure horses by hands, it's roughly 4 inches to a hand. So human beings can come up with whatever they want as long as they all agree. So somewhere along the line, and Debbie's going to find out next time when and who maybe, they decided on something called the AU, astronomical unit, which is the distance, talk about self-centered, from the Earth to the sun, or roughly 93 million miles. So once we start dealing with how far away is the Earth, it's 1 AU, and everything else is based on that. So Sandy's question was the distance in AU to the 4 inner rocky planets. And Ian's going to look them up. And then Regina, I'm gonna, she can't be here today, but she did her homework and I'll hold it up. She wrote out a long page on it. And Regina, I'm not gonna read it. I'm not gonna let you go over it again next time. But basically I will give a synopsis here. Not the distance. I asked her basically we were going through the solar system and how far they were away. And then we got to 2 things that we haven't really talked about. And so I'll just briefly mention them. We'll go into more detail at another time. Once you get out towards Neptune, how many AUs is Neptune away? Is that a list?
30.
30. So whatever the distance from the sun to us, it's 30 times that out to Neptune. When you get out around Neptune, especially just beyond Neptune, there's something called, and I'm not sure how to pronounce it. Who knows, Bob? The Kuiper belt, Kuiper. That's named after some Dutchman or somebody.
Yeah.
Yep.
Hannah and I agree, it's Kuiper.
Kuiper. Okay, did you do some research on that, Bob?
No.
No, I didn't think so. Okay, but that's an area where there are lots of icy, ancient, leftover objects, mostly small, a few larger ones, a few what we call short-term comets, like Halley's Comet that shows up on a somewhat regular basis of 100, 200, 300 years. They all live out there. And every now and again, one gets jostled, or it's a comet now that has a big, long elliptical orbit and shows up every so often. We know exactly when. But every now and again, one of those chunks gets kicked out, and then we might have trouble if it hits us. The other was the Oort cloud, which was not discovered until fairly recently, ORT. And that seems to be, once again, a cloud of no, it's not very dense. You probably would have to go a couple of million miles before you bumped into one, but it's out there. And it's like a sphere around our solar system. And if I'm remembering correctly, and Regina can give you the inner scoop next time, that's where some of our long-term comets come. And once again, if we haven't seen it for 3,000 years, how do we know about it? Because now with our powerful telescopes, we can spot it. We can figure out its trajectory, its path. We can know how fast it's going. And doing the math, we know when it's going to come back. So anyway, Ian, since you looked them up, why don't you start with Mercury? And in AUs, what's the distance from the sun?
0.39.
0.39. I'm going to round it off. 0.4. So it's less than half of 93 million miles. 4/10. What about Venus, our beautiful neighbor?
0.7.
0.7. And then us, everybody?
1.
1. Then what's next? Mars? Mars.
1.5.
1.5. So if we rounded things off, that'd be 150 million miles away. Did I put the asteroid belt in there, or just the next one is Jupiter?
The next one's just Jupiter.
Okay. Before we get to Jupiter, and we won't do it today, but just briefly, there was some scientist, astronomer, mathematician, who figured out a formula of the relationship of the distances of the planets as you went out.
Says the asteroid belt lies between 2.2 and 3.2.
Which is that?
The asteroid belt is between 2.2 and 3.
Do they hear you? I don't.
The asteroid belt is between 2.2 and 3.2 AU.
And according to this scientist, there ought to be a planet there, according to his formula. He's very annoyed. It worked for all 9 planets, including old Pluto. And
I'm
all of us.
sorry.
Okay,
Can you
Mary, what?
Repeat those
All right.
units
2.2
again.
2.2 and 3.2.
That's the asteroid belt.
Yeah.
So it's
So
once
it's
again,
between Mars and Jupiter.
Yeah.
right.
Okay.
Where according to this one theorist, there ought to have been a planet. So of course, people thinking, wow, if the theory holds up for the spacing on all the other planets, but there's none right here, but all these asteroids are here, there must have been a planet once upon a time that got blown up somehow. We'll look into that sometime in the winter when we have nothing to do. Okay, why don't you read off the rest of them slowly so everybody can write it, some are writing it down.
Jupiter is 5.2 AU.
And you can just round it off to the nearest whole number.
Saturn is 9.5. Uranus is 19.2.
Oh,
And Neptune is 30.
And Pluto's 40.
Yep.
And why I know this,
39.5.
I had this wonderful
Oh.
idea and I was going to do it with Jordan 2 weeks ago, and then the weather didn't cooperate. So we are going to do it maybe in March and as a star party. And we are going to walk the solar system, starting at the corner out here by the, just past the kiddie stand. And we're going to head for the post office, which is Pluto, I think. And I have it figured out, 50 feet, whatever.
Says
I think 50 feet for every AU or something like that. And so if the sun is at the corner, then 50 feet away is going to be the Earth. And in between, we have to have Mars and Mercury and Venus, right? Okay, what's that say?
Says Pluto is 3.7 billion miles.
3.7 billion miles.
are we gonna paint circles with the names
Yeah, I
inside?
think we're gonna do chalk. I was thinking colored chalk. And I thought what would be nice, somebody who's good at this sort of thing could make a little card with just real basic information, like the name of the planet and maybe its diameter, and how far away from us it is or whatever, just a few things. And then we could, with a ribbon, tie it around if it's near a telephone pole or something. I don't know what, or a flower pot basket or something like that. I just thought it, and we'd do it as a group. We'd walk it and then we could take pictures of ourselves, a video doing it. Okay,
Sounds good.
it sounds like fun. Okay, Bob, what was your question? I think I remember, but it's too complicated to really get into today.
We weren't there, so we don't have a question.
Oh, right, okay.
Give us a question, we'll wing it.
Okay, well, I think I want to save it. It's for like next time because it's more complicated, but it's how we use the Cepheid stars to tell distance. And I finally found an article that explained it. In most general books, you know, like the 101 college astronomy type books, they mention how, oh, somebody figured out how to measure the more distant stars using the variable stars in Cepheus. But they never explained how they did it. And I finally had an article on it. So I thought we could go into a little detail. And as soon as this gets too scientific, let me know, because I don't want to bore you all, you know, by getting it too. Want to keep it on the light side. All righty, that was page 1. Okay, a pause before we move on with our topic. Did anybody see an example of the sunbeams? We had a fancy name for it that Ian found when he was looking up the various twilight events we could look for. The crepuscular clouds, or otherwise known as sunbeams. Did anybody? Oh, there's Laura now. Her hand's up. Does that mean she?
No, it's just. the
Oh.
mouse.
Is she, Laura, are you there?
I don't know if she's connected to the audio.
Okay. Laura, we're trying to connect you to so we can hear you.
Mhm.
Laura, can you hear us? Can we hear you? Well, you're there.
No. Yeah, I don't know.
Okay, Ian isn't sure how to get you on. So anyway, if you're hearing us, I'll answer what you told me in the car the other day. Laura saw some sunbeams when she was driving somewhere or other, and there was a mix of clouds in the sky, and then the sun in rays that seemed to radiate from the sun shone through the sky around the clouds. All right. Jordan, you're still here? I see a J. Where's Jordan?
Yeah, I'm here.
You're there. Okay, wake up. Did anybody see the Earth's shadow? All righty. The last 3 or 4 nights have been absolutely wonderful, at least from my southerly view. Who saw the crescent moon with Earthshine and glorious Venus all hanging together? And 3 nights in a row, the crescent moon was very low on the horizon as it was getting dark, and Venus was higher towards the east. And each night, the moon got closer, and then it skipped over Venus, and now it's moving away from Venus. Did anybody see that?
No, but last night I saw what I call the string of pearls with Jupiter, Saturn, the moon, and Venus.
All right. Where did you come up with that phrase, string of pearls?
Well, long time ago, and I think I got it out of an astronomy book, that when the planets are all aligned in a row like that, it's called string of pearls.
All right. I think there's another, we can look that up, because I think it also means a certain group of faint stars in a constellation, but I can't remember exactly what.
Okay,
I'm
I
glad
always
you-
heard it. I always heard it in relation to the planets.
Okay, that is, I'm glad you brought that up because I had it down here somewhere. We've talked about the ecliptic, that center line in the highway that goes through the sky, that the sun follows, and then the zodiac is on either side, and the planets and the moon are within, I think, 15 degrees of that. That you could visualize that
Yeah.
ecliptic those nights, because if you started, say, with the crescent moon and then Venus and then Saturn and then Jupiter, it's a curve
Yeah.
going from the southwest higher and higher towards the east. That's the path of the sun. That was the ecliptic, that line. Okay. Now, Bob, you've been down to, and Anne, you've been down to Easter Island, right?
That's correct.
Okay. A week or 2, 3, 4 weeks ago, I asked you all to find Fomahoe, if that's how you pronounce it, the lonely
Ooh.
one. Has anybody managed that?
Would you repeat, find
Okay.
what?
I don't know how to pronounce it. Fomahoe, Foamahault. Because
Oh,
on this clear night, if you followed the crescent moon, Venus, Saturn, and Jupiter, and then took your 2 fingers, Jupiter and Saturn, and dropped them down a short way into a part of the sky where there's nothing much, the star that you see, magnitude 1, is Fomahoe. And it's fairly low on our horizon to the south. But down on Easter Island, it's the Zenith star. It's straight overhead down there. So it's going to cloud up tonight. And so I don't know when we're going to have another clear night, but maybe you all should go and see. Venus is getting brighter and brighter till the beginning of December, higher and higher, and then it's going to start going backwards. and disappear, I think, in January. Okay. Did you find any information on the transit of Venus in 1800s and how they told how they were? I'll start in, and poor Ian, I gave him a last minute complicated assignment here. Back to how do we know? And I thought we'd start with two things: a repeat of how the Greeks figured out the earth was not flat, but a sphere. And then how we figured out the distance to the sun, which we didn't do until the 1800s, which is really not very long ago. So just very quickly, I forget who it was now. I never can remember those Greek names anyway. Somebody like Pythagoras, maybe. But he was a philosopher, scientist, curious person, keeper of records up in Alexandria, where the wonderful library was in northern Egypt. And he was collecting information from travelers. And there was a trader who came up from Aswan, 700 miles to the south. And he noted that in that town, it was famous for the well, because at a certain time of the year, maybe it was the equinox, the sun at noon shone straight down the well, which was very unusual, because up in Alexandria, it never did that. As a matter of fact, the sun at noon always cast a shadow. And this Greek thinker, that was the observation that someone saw with their eyes, applied basic geometry and figured out that the Earth's surface, those 700 miles from north to south, had to be curved. And then using angles and that 700 miles, he was able to figure out within a few hundred miles that the circumference of the Earth was 8,000 miles through the equator to the equator, which meant if you went around it, circumference was 24,000 miles around, and you had a nice big ball.
Bunch of trigonometry.
That's trigonometry for the transit.
Yeah,
Well, okay.
because he used angles.
All right. We won't go into great detail, but in what was the date of those two transits in the 1800s? We have a book here on it that we gave to the library.
Says 1874.
What was
Is
the
that the same?
earlier one? 8
It
years
says that
earlier.
was the first one.
Okay, so in
The
1874,
second one was in 1882.
and the second one was in 1882. Remember, the transit of Venus always happens 8 years apart, and then you have to wait another almost 200 years before it happens again. So in the leading up to that, various astronomers and mathematicians thought, well, now, if we could measure how long it took Venus to transit the sun, in other words, when the little black dot first appeared on one side, and I always forget which side, the right or the left, and then does it take seconds, minutes? How long does it take to go across? Does that say there easily? I don't think it's many minutes or an hour or two. And if you did this at several places around the world, different latitudes, different longitudes, you could then, using trigonometry, Ian says, figure out how far away the sun was.
It says it's about 6 hours and 40 minutes.
Okay, a little over 6.5 hours. Jordan, you don't remember when you were 6 years old, do you? Unfortunately. You still there?
Yeah, I'm still here.
Okay. Because unfortunately, you're not going to live long enough to see it again. But anyway, you were there when you were 6 years old. I got you up out of bed in the morning to see it. So scientists from all the nations in the world, just about, gathered up equipment and teams, and they sailed off, or they went off on horse and buggies or whatever it was to do this. And some were successful, some weren't. Then 8 years later, they did it again and they had better results. And they figured out using trig that that's how far away the sun was. And really, that's amazing when you think about it. We never knew. That was the first step of how do we know how far away something is.
That's when the next one will happen.
2117. Anybody going to be alive in 2117?
Yeah, 118 years old.
118, and Jordan would be 119. Jordan, if you can live to be 119, you can spot it again.
Oh, yeah.
Uh-huh. Yeah. Okay. Now, once again, I did this last time, but I want to do it again. I think it's fun, and some people missed out. Here is another method of measuring how far away something is. Now, I want you all to take one finger, right hand, left hand, doesn't matter, and stick it out in front of your nose and line it up with something across the room from you with one eye. So I'm going to close my left eye. What am I going to aim at? There's a red fish on the wall up there above the books. Cover my left eye, hold out my finger, and I'm blocking the red fish. Then I switch eyes. Uh-oh. Now the fish has jumped to the left of my finger. Why are you laughing? You try it, the blue goose or whatever that is. What?
I did it at home with the door handle.
He did it at home with the door handle. Now, you could have some odd psychologist, I suppose, that says, well, the fish actually moved. And I would say, observe some more, think some more. Okay. What is happening there, guys? Bob?
It's a parallax effect.
All right. We have two eyes.
That's
And
right.
and they're spaced further, they're not right on top of each other, like Cyclops with one eye. I wonder what that would do. Anyway, we have two eyes, binary vision, and yet each eye sees a slightly different version of the world because of the angle that from this eye to the fish and this eye to the fish, the angles are different. How come I don't see two fishes?
Your brain.
Ian, what? They can't hear you.
Your brain fixes it.
That's very good, isn't it? All that crawling around that infant is doing, they're learning. They're learning by touching to connect what they see with their eyes and what they feel with their hands, and then with their brain to realize what reality is. It's really quite amazing what we do all on our own under 2 years of age. Nobody really teaches us anything. We're all learning on our own. Okay, somebody, and I'm sure somebody could find out who that was. I don't know who it was. Suddenly thought, because once again, then using angles and geometry, you can figure out how far away that wall is. We have two eyes in space, the Earth. One, let's say, oh, we have a picture, don't we? I forgot, I'm babbling on. Ian's going to find an image that he looked up.
The parallax one.
The parallax one. Right. So there's the sun in the middle, that little red shining ball.
Second. Can't see it now.
Oh, he's working on it. Click, click. You see it now?
Uh-huh.
Okay. Here's it. The sun in the middle. Here's us up in January, and then us in July, 6 months apart. That's our two eyes. But now, okay, guys, how far away is January from July in space?
8,000 miles.
How many?
8,000. Isn't it?
No, the distance from us.
This is the orbit of the
Yes.
Earth around the sun. Oh,
Yep. How
2
far-
times 92 million, 184 million.
Right, 184 million miles. Now, if I had eyes that far apart, all right. And then we're zeroing in on a fairly close star, let's say Sirius. But in the background, way far, far away, are other stars that we can compare it to. And you see in January, it lines up with this star down here near the bottom. But in July, it lines up with the one in the middle. Ta-da, geometry. So now we can figure out, since we know our distance here, how far away that closer star is. Isn't that clever? Now, oh my, why did I want those other things? Okay. Let's go to the electromagnetic spectrum. Now, this goes back to my original thing about knowledge is limited to how well we can see. Now, I remember as a kid, I'm sure we all played this game. Usually you're in, I don't know, 4th or 5th grade, and somebody comes up and says, if you could only save one of your 5 senses, what would it be? MaryLu, what would you, if you only had one of the 5, what would it be?
You asking me?
Yeah. If you could,
Touch,
huh?
touch.
Really? You'd give up your eyesight and sound for touch?
Well, I think that's because if you only had your eyesight and you couldn't feel anything, I don't know. I think touch you could still see with your fingers.
Okay. Bob, Ann, what would you prefer?
I'd prefer being able to see.
Ann?
Able to see.
Debbie?
I'm
Okay.
too independent to not be able to see.
Yeah. Jordan, how about you?
Wait, what? Sorry, I was distracted.
Okay. What of your 5 senses, if you only could keep one, what would it be?
So probably my sight.
Okay. Ian?
Taste.
Really?
I like food.
He likes food. Taste.
Yay.
He's gonna sit here. We'll be able to hear a thing, see a thing, feel a thing.
No distractions.
No distractions.
Just the food.
Just the food. Oh boy. Okay.
Ian, the problem with that though is that smell and taste
Oh, that's right.
are somewhat
Yeah.
linked. Think about having a
Yes.
cold. If you can't
Mhm.
smell, you're probably not going to have a really good ability to taste either. So you might just want to rethink that one a little bit.
I get super taste when all the other ones disappear.
Okay. Well, I think it's true. We are creatures of the daytime. We don't go wandering around normally at night in the dark. Other creatures can see, can hear better than us, can smell better than us. I don't know about tasting or touching. But we really depend upon our sight for much of our knowledge until fairly recently. So if you study astronomy, all those ancient thousands of years, it was all based on what they could see in the sky and figure out from that. But can they all see this?
Mhm.
Okay, this is the electromagnetic spectrum, which runs from, I like it the other way around, from left, with the radio waves over on this left side, because why? Well, because I read from left to right. I'm not, in the Muslim world, which reads the other way, or the Chinese from top to bottom. So, and I like to start with the less intensive, longer wavelengths on the left side. We can't flip that, can we? Can we flip that? Zip, no. Okay, guys, we'll just work from right to left, but I don't like it set up that way.
I could, but it would take too long.
Take too long. Okay. Nowadays, scientists with their equipment can study the heavens. That includes everything that's out there, pretty much, using all these various forms of energy, from radio waves on through. And we'll just go over a few and talk about them briefly. But before we do that, we should have had a little whatever. Energy such as this can be thought of as traveling in waves or particles. But for what we're dealing with, to understand it as waves traveling through space makes it easier to understand what's going on. And I should have done this ahead of time, but we'll have to use your imagination now. Take your finger and let's make a wiggly wave, like if a speedboat goes through the water. So the wave goes up and then it goes down and then it goes up and then it goes down. All right, you're all doing that? Like a big snake, up and down, up and down. The wavelength, which is what these numbers up here on the top are, is from either crest to crest or bottom to bottom. And the radio waves are very long. Some of them I think that the elephants can hear. We've heard that elephants can make sounds very low down that we can't even hear, can be 2 miles long. So there are such a thing as radio waves. And next week or in 2 weeks, Debbie is going to give a report on the radio telescopes that are there in New Mexico, and what radio waves tell us about whatever is out there. Now, the next thing that I don't know what this is, I'm going to say the next one is microwaves. What is it?
Infrared.
Well, they skipped microwaves and we don't want to do that. Let me find my list. Okay. But before we get there, you've heard of amplitude. When I can't hear something on the radio, I turn the knob and it gets louder. What I've done is I've increased the amplitude, and that is the height of the wave. Think of a very powerful speedboat. It's going to create waves that are maybe 2 feet high from top to bottom. Somebody rowing a boat might just create 3 inches top to bottom. That's amplitude. Loudness, intensity. And then there is the thing that kills you, the frequency. That is how many of those waves are passing at a certain point in a given amount of time. And the higher the frequency, the more waves that pass that point. For us, the more deadly that becomes. For instance, radio waves, in spite of what some people think, will not kill you. Infrared rays, I don't think will kill you unless they can really up the amplitude. Visible light probably won't kill you either. Ultraviolet, you're going to get a bad sunburn. It could possibly kill you, but definitely X-rays and gamma rays will kill you fairly quickly. So that has to do with their frequency. Okay, so each of these areas will, as we focus our equipment on the stars or the planets or their moons or the comets, will give us new information that we don't see with just our eyes, which really, look how skinny a band is there. Okay, Jordan, did you have time to research Green Park down in West Virginia?
I got a little bit of stuff.
Okay, why don't you tell us, because that has to do with radio telescopes, the little bit you found out, why don't you tell us?
What time is it? 10 minutes.
I found that they started
all red delinquent. Yeah.
It's in Green Bank, Virginia.
Oh, Green Bank.
Yeah.
Yeah, and they opened it in, well, they made the National Radio Quiet Zone around it in 1958. The telescope that they have there, I was actually amazed at the size of the telescope. The telescope is 17 million pounds, 2 acres wide, and is 485 feet up in the air.
Okay,
I
hang
think
on a
it's pretty
minute.
crazy.
So 2 acres is about a little over 400 feet in diameter. All right. And
Yeah,
how many feet up in the air?
485.
Wow, that's like a 40-story building at 10 feet. Yeah. All right. And what does it do, or what is this quiet zone?
Now they use it to, I think using the waves, they can detect things from very far out in space. Read it was like billions and billions of light years out in space. I think around 10, it was between 10 to 20 billion light years, I think.
That's a long ways
And
out.
so they need the radio quiet zone around it because the sounds that they're looking for are, I think, less than 1/10 of a watt
That's not
from
very
out in
bright.
space.
Okay.
So they need to keep all like cell phones, laptops, anything off around it because they make a sound that can disrupt the telescope. Because
Okay.
what I was reading is anything that you could have a cell phone that's at like 3 and that's way too loud for it, and they can miss stuff from out in space.
All right. How far out from town does this quiet zone go?
I think they said it was 13,000 square acres around it.
Oh. I need paper and pencil to figure that one out. I had read somewhere, oh, the quiet zone, that we have a book. If anybody wants to take it out and read, it's called The Quiet Zone. I had heard it was 50-mile radius, but I can't translate in my head square acres. Does that mean microwave ovens too, right?
Yeah, so they have guys that drive around looking for anything. They have like detection on their cars for any form of radio sound. So they just drive around the area,
It's like
hunting down anyone that is violating it, and they just tell them to stop. I think one they said was a guy had a malfunctioning electric blanket that they had to confiscate.
Oh.
this is like the
Yeah.
weed police. Okay, that's pretty funny. So who all lives there in this strange?
There's a lot of staff, and now they're getting a lot of people that don't want to live near electronics or think that they're allergic to electronics or those kind of people.
Yep.
Some news articles I said that there were like neo-Nazis and stuff that are moving there now
No, great.
to avoid stuff, I guess. The locals aren't that happy about it,
Yeah.
but all sorts of people. But yeah, there's some people that think that it's a CIA operation.
Oh,
So conspiracy theorists.
what does it say?
But there's also a lot of people that are
Radius?
just staff, I think.
Right. Well, okay, in the front of this book is a map, and it's a 10-mile radius. So Hornell's about 13 miles from Hornell's about 10 miles from Alfred. So it'd be everybody living in that amount of space from here to Hornell and in all directions. So we couldn't be doing a Zoom talk, could we? All righty. Well, the
No.
article I'd heard
Do
was that
anything.
that it was a strange combination of scientists who live there and then these whatever you want to call them, people that believe waves are, these kind of invisible waves are harmful to their health. So anyway, okay, anything else on that, Jordan?
One other thing I found interesting from one news article I saw about is they interviewed some people that said since they can't call each other, I think you can only call each other through landlines.
Right.
Some people communicate with each other by, there's a supermarket near one of the towns, and they have like a conveyor belt with sticky notes that people put for messages for other people in the town.
Okay.
Everyone can just go there and see what other people had to say. Yeah, I thought that was kind of cool though.
Oh, like a Facebook sticky post-its. Okay. Well, human beings are known for their ingenuity, and they have certain needs, and they're going to figure out how to do it no matter what, right? But I didn't know about the, what shall we call them? The electronic police?
Yeah.
Give me that blanket. You can't have it. All right. Questions for next time, because we're running out of time here. Where are my questions? Ba-doop-a-doop-a-doo. Assign. All righty. MaryLu, why don't you deal in more depth with radio waves? Okay.
Ah,
Why are they, what can we hear that we can't see? Or why are they good? What's their advantage? Sandy's not here, so if I get hold of her, she's going to deal with microwaves. Ian, you're going to have infrared. Okay. Regina is going to do ultraviolet, and you have X-rays. And Bob, you have the gamma rays. Does anybody know, is that 1 or 2 M's?
2.
2. Good, I spelled it right. All right, Jordan, you already did, what was the name of the place?
Green Bank.
Green Bank. Gotta change that. Okay. And Debbie's going to give us a report on that series of radio telescopes up in New Mexico.
Sounds good.
And we're going to give Rima visible light color. And these, I think we should focus on how they affect our knowledge in astronomy. And Ian, can you click on this one here, the spectrum?
can you repeat those?
All of them or just yours, MaryLu?
No, all of them. I had radio waves.
Okay, Sandy had micro,
Sandy had microwaves.
Ian had infrared,
Okay.
Regina ultraviolet, abbreviate. Ann X-rays, Bob gamma rays, Debbie the radio tower, the radio telescopes, and Rima visible light, which is what we're looking at here. One of the 4 images. We didn't get to all of our images, so we can save them, right? Okay. Next time, when we get to visible light, Ian found the night sky with a whole bunch of big bright stars that we all love, and they're all different colors. So we'll talk about what that tells us. So here is old Newton, stuck because of the plague, and he had to go home, and he shone the light through the prism, and lo and behold, there was the rainbow on the wall. Read Roy G. Biv. Each of those colors is a different wavelength, and each one, the longer wavelength is the red and the shortest is the violet, which means the violet light is more intense. Its frequency is higher than the red. And when we have a whole unit on what color tells us, we already know because we went through that, right? The red stars, are they cooler or hotter?
They're cooler.
Cooler. And as we move through the spectrum to the blue ones, the blue-white ones, they're the hottest and usually the youngest. Okay, anybody, it must be getting time. Does anybody have any questions? Laura, we see your name, and I don't know whether you've heard this, but he recorded it. So if you had trouble, once again, you can email Rima here at the library and she can tell you how to get hooked up where we can hear you as well as see your name.
I think she can hear now.
You think she can hear now, but she can't respond?
She's muted.
She's muted. Okay. You are muted, Laura, so we can't hear you by accident or design. Okay, is that it, folks?
She said hello.
You heard her say hello?
She told me to say, she said hello.
Oh, okay. All right. From New York to the West Coast, back here. Very good. Okay, guys, see you in 2 weeks.